For over 4,500 years, it has stood as a symbol of human genius, the last surviving wonder of the ancient world. The Great Pyramid of Giza defies time, weather, and understanding. Built without cranes, computers, or lasers, it remains the most precise and enduring monument in history. Even today, engineers marvel at how it was possible. Could we rebuild it now? And if so, what would it take to engineer the impossible once again? The Great Pyramid was built for Pharaoh Khufu around 2560 BC. Rising 481 feet tall, its four sides align almost perfectly to true north, an error margin of less than 1/10 of a degree. Over 2.3 million limestone and granite blocks, some weighing more than 15 tons, were placed with surgical precision. Each block fits so tightly that even a razor blade can't pass between them. Its base spans 13 acres, with side lengths accurate within just a few inches. Proof that this was more than architecture. It was astronomy, geometry, and faith fused into stone. The question is how? Theories abound. Some believe a massive straight ramp stretched for miles into the desert. Others propose spiral ramps wrapping around the pyramid's core, or intricate counterweight systems hidden within its geometry. The truth remains uncertain. But what's undeniable is that the ancient Egyptians achieved the impossible with tools no more advanced than copper chisels and rope. Modern engineers now have access to robotics, AI, and advanced surveying equipment. Yet even with all our technology, replicating their precision would be a monumental challenge. If we were to rebuild the Great Pyramid today, we'd begin with digital precision. Engineers would map every contour using 3D laser scanning and satellite data. AI-driven modeling would simulate stress points, foundation loads, and material durability, ensuring the same geometry that's lasted millennia. Materials would be a mix of tradition and innovation. Limestone and granite reinforced with carbon composites for longevity. Prefabrication yards would cut and polish each block with micron-level precision, guided by robotic arms. Autonomous haulers and magnetic levitation cranes would transport and place stones weighing up to 20 tons with sub-millimeter accuracy. Powering this mega-build would require its own energy infrastructure. Solar fields spread across the desert would drive the entire operation, powering cranes, AI systems, and fabrication plants. Instead of thousands of laborers pulling stones by hand, a fleet of synchronized robots and drones would lift, position, and align each piece in perfect sequence. Yet even with all this machinery, the cost of rebuilding would be staggering. An estimated $5 to $6 billion and more than a decade of global collaboration. But the true challenge wouldn't just be logistics, it would be precision. The ancient Egyptians achieved something modern builders rarely do: perfections without error. The Great Pyramid's alignment to celestial north suggests that its builders studied the stars for accuracy. Modern engineers would use GPS satellites and laser gyroscopes, tools of millimeter precision, to replicate what was once done by the naked eye. Each layer would be aligned through AI algorithms, ensuring stability for thousands of years. Inside, the Great Gallery, King's Chamber, and relieving chambers could be reconstructed with reinforced materials. Sensors would monitor structural stress, temperature, and vibration, turning the ancient design into a living smart monument. But a modern pyramid wouldn't just be a replica. It could be a fusion of past and future. Imagine a structure that honors the pharaohs but embodies sustainability. Solar glass panels could line the upper tiers, transforming sunlight into power. Ventilation shafts, once aligned to Orion's belt, could now regulate airflow, The pyramid could stand not as a tomb, but as a monument to renewable energy, a beacon of innovation in the desert. Its carbon footprint, net zero. Its purpose, a museum of human progress, one that connects ancient mastery with future possibility. Rebuilding the Great Pyramid would also be a symbolic act, a message to the world that greatness isn't about speed or convenience, it's about precision, patience, and vision. The ancients built for eternity. We build for profit. To rebuild their wonder would be to rediscover what humanity once valued most: permanence. The project would require international collaboration. Architects from Europe, engineers from Asia, scientists from the US, and craftsmen from Egypt itself. A unified effort to recreate not just a monument, but a shared legacy of innovation. In the end, the real question isn't, can we rebuild it? It's, should we? The Great Pyramid already stands, defying time and technology alike. Perhaps the true wonder lies not in rebuilding it, but in understanding how it continues to endure. Because maybe the ancients weren't just building a tomb, maybe they were building a message. One carved in stone telling us that the greatest engineering isn't measured in height or cost, but in eternity. The Great Pyramid of Giza, a timeless riddle, an eternal masterpiece, and a challenge that even today dares humanity to reach higher. Rebuilding it would not just recreate the past, it would redefine the future. A monument born of stone and stars, engineered for the impossible, built for forever.